Antiferromagnetism is when the electrons within a material coalesce, forming a chain of oppositely charged particles, even though the material as a whole does not appear to have any magnetic quality. Antiferromagnetism is the opposite of ferromagnetism, where particles align themselves, and occurs in materials such as manganese oxide. The phenomenon generally decreases as the temperature rises, the electrons scattering arbitrarily and no longer forming chains. The temperature at which this occurs is referred to as the Néel temperature. The name antiferromagnetism is derived from the opposite term, ferromagnetism. In ferromagnetism, particles within a material align themselves within a domain so that within that specific domain, the material is magnetic. This can be hard to find externally, because there are many different groups of particles that are not aligned in the same way as each other. One ferromagnetic material is iron. The Latin word for iron, ferrum, is where the word ferromagnetic derives from. Ferromagnetic materials can be made to be magnetic with the use of an external magnetic field, and they are often used for electromagnets. Antiferromagnetism means that the electrons within the material do not align themselves with the same magnetic polarity. Even within the specific domains, the material does not display any magnetic qualities. As a result of the electrons not aligning themselves in the same polarity, they cancel each other out with the specific chain of electrons. This is different from ferromagnetism, because in ferromagnetic materials, the chains consist of electrons with matching polarity, but the different chains cancel each other out. Louis Néel, a French physicist, found the temperature at which the highest possible level of magnetism can be produced in an antiferromagnetic material, now called the Néel temperature. As the temperature steadily increases, some of the oppositely aligned particles can break free of their chains and arrange themselves according to an external field. Each material has a different Néel temperature. For example, the one for manganese oxide is -240 degrees Fahrenheit, 151 degrees Celsius, but others can be equal to or greater than room temperature. Above the Néel temperature, the electrons that break free of the chains produced by antiferromagnetism cannot form into even the weak magnetic groups that they can at lower temperatures. As the temperature gets higher and higher, the level of disorder within the atomic structure of the material increases, thereby decreasing its level of magnetism.